me go ahead and ask if there are any questions.
Louisa?
Yeah.
I'm trying to figure out where the tool function was, and I click on tools and services, but I didn't get that same set of tools that you had.
If you just let your mouse hover over any of the images, you see there's like a screwdriver and a wrench.
Oh, okay.
Yeah, that's interesting. I will, the stuff that's up here is meant to refer to NASA, for URSA as a whole, so all of URSA's information and all of URSA's missions, and so all of URSA's tools and services are up here. So, yeah, sorry, I don't know how, that's a good point. I don't know how we can make that less confusing, but I will think about it. In order to get,
Thank you.
yeah, in order to get to the tools, yeah, you just let your mouse hover over the image. More questions?
Louisa, this is Merrill.
Hi, Merrill.
Hi. Is there any, say, recommended signal-to-noise ratios that we should, be thinking about when we're looking at these different readings for the different cameras?
It depends on what kind of science you're doing. My basic rule of thumb, just in general, for life in general, signal to noise of 3 or less is really, really low significance. You would have to be really convinced that there was a source there to believe a signal to noise of 3 or less. For the WISE catalog in general, I think I might only take a signal to noise ratio of 10 or greater, but again, it depends on the kind of science you're doing. Since the images aren't calibrated, you can't do photometry on your own. So they've done photometry in absolutely everything that might possibly be there. And so pretty much that's why the signal to noise ratios can be so low in the catalog, is because they're trying to help you. But what that means is you also have to be an educated consumer, right? And look at the images and look at the quality flags and only take the stuff that you believe in.
Okay. Let me ask another one then real quick. In comparing objects on the WISE versus object in Spitzer for some of the research we've been doing, it seems like there's just sometimes a very slight differential in RA and DEC. Is there any reason for that, or is it? I have noticed in the notes that there's some, like 0.05%, potential error or something like that. I forget.
That matches pretty well. Matches pretty well. Yeah. The 2MASS survey, which is the ground-based near-infrared survey, established really good coordinates over the whole sky. And so IRAC and therefore MIPS and IRS's coordinates, the Spitzer coordinates, are tied to the 2MASS coordinate system, as are the WISE coordinates. So they should all match each other for the same source within an arcsecond.
Within an arcsecond?
Yeah.
Okay.
But Planck is one that you have to be wary of.
Yes. Planck is a different beast entirely.
And Louisa?
Yeah?
Yeah, hi. Concerning the uncertainty in the W1 band, what sigma, whatever, what's a good difference there? Is it?
Well, you have to look at the uncertainties in conjunction with the signal-to-noise ratio.
Oh,
Okay, so, I mean, just looking at this little catalog excerpt I've got on the screen here, you've got several objects that have really high signal to noise, and they all have about the same error, 0.02, 0.03-ish. But then you have this beast, which has a signal to noise of only 9.8, which, then it therefore has a fairly large error. So those things are going to be connected, but there's going to be a rollover, right? There's going to be a asymptotically approaching floor. In other words, there's some fundamental uncertainties that can't be reduced that come, from photon statistics and other processing steps, and so it's going to plateau at a certain level. So yeah, if you go get a catalog, you can plot up the errors in magnitudes against the signal-to-noise ratio and see exactly how they're related. It's not just a mathematical equation between the two of them, because it also has to do with what the background level is. So all of these things are all connected, but in some reasonably understood ways. More questions? I've either blown you all out of the water or you already knew it all. Are there more people that dialed in that I didn't catch your name. Some people have already left, but I want to try to make a note of how many people came so that we can decide whether or not we should do this again. Is there anybody who hasn't yet told me that they're on the phone?
Please do this again.
Yeah, there was a lot of enthusiasm from you guys on a lot of different topics, so I'm going to try to line up some more speakers besides just me. I don't know if we're going to get a chance to do any before the AAS, but we will try and pick it up end of January, beginning of February.
Well, Louise, another quick question. Are the objects in WISE classified in any way? So in other words, like FDSS, you know, you can look for all objects that are quasars. Is there any sort of division like that at all, or categorization?
So there's a complex answer to that. So remember from the talk part, there was let's see, there was this image here. Okay, this right here tells part of the story. Okay, because that WISE PSF, that's pretty circular and it looks like a point source, but in Sloan you can see that it's fuzzy. Because Sloan's spatial resolution is higher, Sloan can do some simple categorization of objects based on shape that WISE simply can't. So that's part of it. Part of it is that Sloan has 5 bands in the optical. And so they can do a lot more segregation of sources. WISE has only 4 bands in the infrared, where the dynamics of the SEDs, of the spectral energy distributions that are seen of the underlying objects, are not necessarily changing as rapidly. And so based just on WISE, or just even 2-mass in WISE, you can have a similar shaped SED for a wide variety of objects. And so it turns out to be a lot harder to categorize objects in the same fashion that you're familiar with from Sloan.
Okay, that makes sense.
But the thing is that Sloan plus 2-mass plus WISE is actually quite powerful. So in those regions where you do have Sloan data, you can do a lot.
Great.
All right, more questions? Hey, we're even ending on time. Thank you guys very much for calling in. I'm going to send around a survey in a little bit so that you can tell me if I went too fast, too high level, too slow, so that we can try to make this work even better next time.
Just awesome.
All right.
Thank you.
Thanks a lot, you guys.
Thank you.
Bye.
Bye.